The Forest Plot. Welcome to Everything Surgery, where we dissect the extraordinary in medicine. Today, we are delving into a fundamental tool in evidence synthesis, the forest plot. A forest plot is a graphical display that is essential for presenting the results of meta-analyses. Its strength lies in its ability to show, in a single visual, the individual results of multiple studies, the overall combined outcome, and the degree of variability between them. Let's walk through how to interpret a forest plot, focusing on its core components and their meaning for clinical research. Core components of a forest plot. Picture a typical forest plot with a column of studies on the left and a graph on the right. Here's what you'll encounter. The left-hand side, study information. This section identifies each study included in the analysis. It usually lists the first author's name and publication year, such as Smith et al., 2020. Alongside, you will find columns showing numerical data for each study. For binary outcomes, this includes the number of events and total patients in each group. For continuous outcomes, it presents the mean and standard deviation. Most importantly, it displays the calculated effect size, such as odds ratio, risk ratio, or mean difference, and the confidence interval for each study. The graph, visual representation. This is the heart of the forest plot. The horizontal line at the bottom, often on a logarithmic scale, represents the magnitude of the effect. A vertical line, known as the line of no effect, runs through this axis. This line symbolizes the null hypothesis. For example, an odds ratio of 1 or a risk difference of 0. For each study, you will see a square or another shape at the center. This represents the study's point estimate or effect size. The size of the square is proportional to the study's weight in the meta-analysis. Larger squares indicate studies with more precision, typically due to larger sample sizes or more events, and thus greater influence on the overall result. Extending from each square is a horizontal line, which represents the study's confidence interval. This shows the range within which the true effect is likely to lie. A longer line means the estimate is less precise. If this line crosses the vertical line of no effect, the study's result is not considered statistically significant. The bottom, summary information. At the bottom, you will find a diamond shape. This represents the pooled, overall result of the meta-analysis. The center line of the diamond indicates the summary effect size, while the horizontal tips show the confidence interval for the pooled result. A narrower diamond means a more precise overall estimate. Step-by-step interpretation guide. Let us systematically interpret a forest plot. Step 1. Identify the outcome and effect measure first. Determine what outcome is being measured and the effect metric used, such as odds ratio or mean difference. Step 2. Find the line of no effect. Next, locate the vertical line that represents no effect. This is your reference point for statistical significance. Step 3. Examine the individual studies. Direction of effect. Are most of the point estimates on one side of the line of no effect? This indicates consistency in findings. If they are scattered on both sides, it suggests no clear effect or conflicting results. Precision. Confidence intervals that are short indicate precise estimates. Studies with wide intervals are less precise and contribute less to the overall result. Statistical significance. Studies whose confidence intervals do not cross the line of no effect are statistically significant. Step 4. Assess heterogeneity. Good overlap. If the confidence intervals overlap substantially, it indicates the studies are statistically consistent and differences may be due to chance. Poor overlap. If intervals do not overlap well or if point estimates are on opposite sides of the line of no effect, this signals heterogeneity. The results differ more than expected by chance. Statistical measures like I-squared and the Q-test p-value, often provided alongside the plot, can confirm this impression. Step 5. Look at the overall result. The summary effect. Where is the center of the diamond relative to the line of no effect? This tells you the direction and magnitude of the combined effect. Statistical significance of the summary effect. Does the diamond touch or cross the line of no effect? If it does not cross, the overall result is statistically significant, suggesting confidence in the intervention's effect. If it does cross, the overall result is not statistically significant, indicating that the intervention's effect cannot be confirmed. An example interpretation. Imagine a forest plot summarizing 8 studies on a new drug for lowering blood pressure. The effect measure is the mean difference in systolic blood pressure, with the line of no effect at 0. Most point estimates are to the left of the 0 line, with values such as -5, -8, and -12, suggesting the drug lowers blood pressure. One study's confidence interval is very wide and crosses zero, indicating a lack of precision and statistical significance, and its influence is minimal. The confidence intervals of the other 7 studies mostly overlap, showing consistency. At the bottom, the center of the diamond is at -7.5, with its tips extending from -9.0 to -6.0. The diamond does not cross the zero line. Interpretation. The pooled results from this meta-analysis of 8 trials, represented by the diamond, demonstrate a statistically significant reduction in systolic blood pressure of 7.5 mm of mercury compared to placebo. The confidence interval ranges from -9.0 to -6.0. Individual study results were largely consistent, supporting the robustness of this finding. In summary, the forest plot is a powerful and efficient tool that visually summarizes complex evidence, enabling clinicians and researchers to quickly grasp the findings of individual studies, the consistency between them, and the overall conclusion of a meta-analysis. Thank you for joining us. If you enjoyed this episode, please like, share, and subscribe. This is the Everything Surgery podcast, where we bring clarity to the extraordinary world of medicine.